All right, we're going to take a look at part two of rational functions. And so you can reread through the beginning part of the notes to remind you. A couple of things that we touched on in part one was being able to identify a vertical asymptote. So again, that's an invisible vertical line that points of a function approach but never actually reach. And so we denote that on our graphs with kind of these dotted lines, and our lines and our curves will actually get very close and approach it, but never actually touch those lines. Okay, and so we spent a little bit of time determining what those vertical asymptotes were. And so we looked at the denominator of our rational function and saw that if we set that factor, those terms, equal to 0 and solved, that would give us our vertical asymptote. So we look at that first one, x minus 2 in the denominator, set that equal to 0. And so if I had x minus 2 equals 0, I would eventually get x equals 2 when I scoot it over. And that's actually going to be our vertical asymptote. We see also on this other one, we have a difference of perfect squares, x squared minus 9. We can factor that out and see that the 0 values would be x equals 3 and x equals negative 3. And that is actually going to be the identity of both of our vertical asymptotes, you can see by the dotted green line. There was another feature that we also discovered in this when we're able to actually factor out the rational functions and then have like terms in the top and bottom. We can cancel those things out. When we have, in this case, x plus 1 canceled out, that tells me that there's going to be a hole. That means there's going to be a point on my actual graph that there is going to be no output. There's going to be no y value. And so we can actually determine exactly where that is. And so we set our factor that we cancel out equal to 0. And then that is going to be our x term. So we have x plus 1 equals 0. We scoot over the 1. We get x equals negative 1. That's going to be my x term of the whole. Then I take that newly discovered x term of negative 1 and I plug it in for x in the reduced function. After I've canceled out the factors, I plug that value in. You see that here in the green. And so the value that I get when I plug negative 1 in is negative 2 in this case. And so my hole on my graph is going to be at the point negative 1 and negative 2. And you look over on the graph there, we see that open circle to represent that there is no actual y output at that point. All right, so we kind of summarized that with these terms down here. And then we went through a couple of examples here again. So we have, again, a difference of perfect squares that we factor out. We have one that we cancel. And so we're able to determine that it does have a hole. Now, we also notice that there is no term left in the denominator by itself. And so there will be no vertical asymptotes if we cancel out the term. There will be a hole, but no vertical asymptote. Look at the one in the middle here. We got x plus 2 by itself. It can't be canceled out. And so therefore, we could take that term set equal to 0, and that's going to be our vertical asymptote. There is no hole for our second example. All right, then on our third one, we see that we have factored each of these things out. We have x plus 2 that gets canceled. Therefore, that's going to be our hole. Our negative 2 is going to be our x value. Plug it back into the reduced function. You see in the green there up to the right. And we see that the y term will be 1/2. Now, there is still a factor left over in the denominator, x plus 4. And so we can set that equal to 0 and see that x equals negative 4. So the vertical asymptote will be at x equals negative 4. All right, we kind of summarize some of those things up here and give a couple more examples of very similar things that we just practiced. All right, so you can take a closer look at those if you want to review. But we're going to move forward here talking about horizontal asymptotes. All right, so vertical is obviously up and down. Horizontal is left and right. Same idea. Now it's going to be a imaginary or not a invisible horizontal line that the graph will approach but never actually touch. All right, so very similar in understanding. It's just going to be horizontal in this case. All right, so if we look at these different tables, kind of similarly to how we did in part one, we see that as our x value increases, our y value is getting closer and closer to 0. And so y is approaching 0. And so our vertical asymptote would then actually be y equals 0. All right, if we look at this second one, okay, we see that as x is increasing, our y value is getting closer and closer to 2. And so our horizontal asymptote will be y is equal to 2. And then we see in our third table there that as x is increasing, okay, the y value continues to increase. There doesn't seem to be an actual limit. And so it is approaching infinity. So therefore, there is actually no horizontal asymptote. All right. Now we have kind of our rules to help us figure this out. So there's 3 different scenarios. And the key here is that a graph must have at most one horizontal asymptote. We've already seen in previous examples that you might be able to have more than one vertical asymptote, but you may only have at most one horizontal asymptote. So if the degree of the numerator is less than the degree of the denominator, so we're looking at, as we can see over here, all right, this is just like x to the first, and then we got x to the third. So we're comparing those exponents, notice the degree. And so if the degree of the numerator is less than that of the denominator, then y, or the horizontal asymptote is y equals 0. Now, if they are equal to each other, so we got 2x here, which is just x to the first, over x, which is x to the first, those are equal in terms of degree. Then we're going to take the coefficients in front of them and make a ratio, y equals a over b. Okay, and so that will be our horizontal asymptote. And so in this case, coefficient is 2, coefficient not given is 1. Okay, so my y equals 2 over 1, or just 1 would be my horizontal asymptote. Okay. And then lastly, if the numerator has a greater degree than the denominator, there will be no. All right, so we got 1 at 0 if it's less than. If it's greater than, there's going to be none. And if they're equal, there's going to be a ratio of coefficients. All right, so let's take a look at these examples here and see if we can determine what the horizontal asymptote, if any, will be. All right, so if we look at 1, or look at A, we see that there is no x term, okay, but there is a y term. So technically, okay, the top term is less than the bottom term. And so our horizontal asymptote will be y equals 0. All right, so again, we're talking about the degree of the numerator is less than the denominator. And so therefore, y will equal 0. All right, if I look over at this next one, I see x to the first, x to the first. Okay, so those are equal to each other. So I take a ratio of the coefficients. And so again, if the numerator is equal to the denominator, then it's going to be y equals a over b, which will be y equals 1 over 3. All right. So we take a look at C. See, x to the first and x squared. Okay, if the degree in the numerator is less than that of the denominator, just like our first example, okay, then it'll be y equals 0. All right, so take a second, see if you can answer D, E, and F on your own before I go through them. See if they're starting to ring a bell a little bit for you. All right, so our degrees are equal. Therefore, it's going to be a ratio of coefficients, so 3 over 1, or just y equals 3. Okay. All right, I see that the numerator is less than the denominator. And just like the examples before, that means that it's going to be y equals 0. All right, then I look at this one. If I FOIL this out, I'd end up with an x squared in the numerator, just x on the denominator. Therefore, the numerator is greater than the denominator, and so therefore there will be no horizontal asymptote. All right, so that's how we figure out the asymptotes. Now, let's kind of put it all together, what we've learned in the last part and this part with this rational function. Okay, so remember, figuring out a vertical asymptote, we look in the denominator and we set it equal to 0. So I got the term x plus 3 equals 0, x equals negative 3. So that is going to be my vertical asymptote. There is no term that is canceled out, and so there will be no hole. Okay, my horizontal asymptote, all right, my numerator equals my denominator. All right, so I look at the coefficients in front, and it's just going to be 1 over 1, so it's going to be y equals 1. Okay. All right, then my intercepts. Remember, my y-intercept is when I set y equal to 0. My x-intercept is when I set x equal to 0. So I take the function, and so if I had y equals 0, okay, then I would have 0 equals x minus 5 over x plus 3. All right, so what do? Well, I'm still trying to solve for x, and so I'm going to multiply each side by x plus 3. All right, those will cancel out. That will still be 0. So we got 0 equals x minus 5, x equals 5. So if I got 5 and 0, that will be my x-intercept. And my y-intercept is when I put x as 0. So if I have my y equals x minus 5 over x plus 3, and I plug in 0 for x, I'll have 0 minus 5 over 0 plus 3, and that's going to equal negative 5 thirds. So my coordinate will be negative 5 thirds. All right. Okay. So I got some information here that I can use. And so we'll use green. I'll make this line a little thicker. Okay, so my vertical asymptote is at x equals negative 3. So I draw that dotted line in. I'm going to have no hole. My horizontal asymptote is going to be at y equals 1. So I draw that down there. My x-intercept is going to be at 5, 0. And so I got 5 and 0. So I know that's going to be a point right there. And then my y-intercept is going to be at 0, negative 5 thirds. So 0, negative 5 thirds is somewhere right about there. All right. And so to draw this bottom part, if I got those, I'm going to end up curving. I'll use different color, a little thicker. It'll be something along the lines like that. All right. So I have those intercepts. That's really helpful in order to kind of make my curve. But do I have any other values that I can actually plot? Well, I do. And so if I look over on this side over here, okay, I need to make a table. All right, just real fast, a little XY table. All right, because I got all these negative values to the left of the vertical asymptote of negative 3. I kind of want to see what that's going to be. So if I put in negative 4, okay, for x, negative 4, and negative 4 minus 5 gives me negative 9. And negative 4 plus 3 gives me negative 1. So I got negative 9, okay, over negative 1, or just 9. Okay, so I'm going to have a point of -4 and then 9. I'm going to have that up here. All right. And if I went and did, let's say, I don't know, -10. All right. I'll get -10 minus 5 will give me -15. -10 plus 3 gives me 7. -15 over 7 is a little bit more than -2. And so if I was out here, I would be somewhere along the lines of here. All right. So I start to see they're going to mirror in terms of curve. I'm going to have something along the lines of that. Okay, and I could put more values on there in between to help give me a little bit more accurate, but I'm pretty confident in these shapes based off of a couple of those points and the information I was able to gather. All right, so we got another example here. It's our last one. And so I could see that I'm going to have a term x plus 2 on top. I got the difference of perfect squares, so this is going to be an x plus 2, x minus 2. Because of that, I'm going to have two terms that cancel out. I have one term that's left over, so this is going to be my vertical asymptote, and that's going to be x equals 2. So I got x equals 2. All right, the hole that I have, okay, I'm going to set x plus 2 equals 0, so x equals -2. So that's going to be my x coordinate. Okay, and then I plug -2 back into the reduced function, which will be 1 over x minus 2. Plug in -2 for x. I get x is 1, or sorry, I get 1 over -4. So 1, -1/4. All right, so all I did is I took -2, plugged it back in right there. Since I cancel out the term up top, I just put a 1 in there. So it's 1 over x minus 2, but I put -2 in for x. -2 minus -2 is -4. So that's how I get the whole. All right, so I take a look also at the horizontal asymptote. All right, and I see that the numerator is less than the denominator. And that tells me that my horizontal asymptote is going to be at y equals 0. All right, take a look at the x-intercept and y-intercept. Again, this is when y equals 0. This is when x equals 0. And so if I have each of these equations, okay, then I will have, if I have y equals x plus 2 over x plus 2, x minus 2, all right, if that's going to be 0, okay. Now, I could just kind of keep that in x squared minus 4, because I'm going to end up having to take each of those terms anyway and put it onto the other side. And so if I multiplied, I'm going to kind of put that back in its original form, just to make it a little bit easier actually. Multiply by x squared minus 4 on both sides. Those will cancel. That still remains 0. So we got 0 equals x plus 2, and then x equals -2. All right, so it's going to be -2 and 0. All right. And so if we took a look at our y-intercept, okay, our y-intercept is going to be, if I put 0 in for x and then solve. So I got my y-intercept. It's going to be, all right, y equals x plus 2 over x squared minus 4. Plug in 0 for each of those. 0 plus 2 over 0 squared minus 4. I'm going to end up with -1/2. So it's going to be 0 and -1/2. All right. And so let's take a look here. Okay. So one thing that this is kind of a unique scenario, is that, all right, I just found that I got a -2 as my x value. And so I put that right here. Now, the interesting thing is that I just figured out that there's going to be a hole at -2 and -1/4. All right, so at -2, it can't also have a value of 0. And so since we know that our hole is correct at that point, there actually will end up being no x-intercept. This does not always happen, but it can. It's just a small thing to keep a lookout. So if there is no x-intercept, and we got a hole at -2 and -1/4, there's going to be one somewhere right around there. All right, so if we drew in our information that we have now, okay, that we clarified those things, we got a vertical asymptote at x is 2. Okay, I got a horizontal asymptote right there on the x-axis. Okay, we drew in our hole at -2 and -1/4. Our y-intercept is going to be at 0, -1/2. Somewhere right about there. I'll fill that in. All right. So if that's the case, we know the asymptote's right here at 2. It's going to be right along there. I could draw in a, doesn't go through, somewhere right along there. All right, doesn't have to be perfect, but you can tell that we're not going to cross that asymptote. All right, so similarly to what we did on the previous one, we got to do a little table over here to find out what the graph will look like on this end. So we can pick a value. All right, so if we picked, 3, all right, plug in 3 plus 2 is 5. 3 squared is 9 minus 4 is 5. All right, so 5 over 5 is 1. So we got 3 and 1. There's a point right there. All right, if I put 4 in, I'm going to get 4 plus 2 is 6. Okay, 4 squared is 16. Minus 4 is 12. All right, so now we got 6 over 12, or 1/2. All right, so we see we're going to be getting lower. All right, so now I got an idea that this is going to come that direction. This is going to come up that way. And so now we have our graph. All right. Okay, so we reviewed over our vertical asymptotes, how to find the hole. Okay, horizontal asymptote was new. We kind of refreshed on x and y intercepts, which we've done before, but not necessarily within this unit yet. All right, and so we were able to find that for each of these. We saw kind of an anomaly here where we're going to have where we had our hole and our x-intercept at the same value. That can't happen, and so we end up not having an x-intercept. And we just see that it doesn't go across that line anyway, which makes sense. And so we were able to make our graph in this sort of shape. So work on the homework, get some practice on plotting these things. The graph plotting can be a little bit tricky, but the biggest thing that we want to figure out, okay, are these values. If you're able to figure out these values, okay, with some practice, we can learn to plot them on a graph better. So that's secondary to figuring out these values. All right, guys, have a great weekend. Thanks.